Chris, and this is a great question. I'm confusing in my mind and memory the number it takes on average to get a red card versus the number on average it takes to get one of each card. I believe the answer to that one is 3, because it should be higher. It should be higher because on average you're going to get, the average result is you're going to get one and then the other, if that makes sense. But you also have to allow for the possibility of a double up on the first. So I'm going by memory, which is always dangerous in this respect. We could run the math on that one, which we actually, the Gambler's Ruin quiz, if you guys did that in 243, I'm not even sure if I had it when you took me in 243. I made that one up last term.
I took it like a year ago.
It was a year ago, yeah. And in 243 last term, I made the Gambler's Ruin quiz, which was super fun. A good way of showing why gamblers ruin themselves, you know, with this idea, like keep playing, or go home. Cut your losses and go home. Enjoy yourself while you're there, and then learn to stop. But it's that geometric idea that was in that quiz, so great times. Tell me your name again. Brandon asked me a phenomenal question before the cameras. I want to make sure that the world hears it, and when I say the world, the 5 of you that watch this video. Brandon, what was the question?
Are you ever going to let us know whether or not your deck is rigged?
Are you ever going to let us, am I ever going to let you know whether that deck I played with you guys yesterday is rigged? My answer to him?
No.
No, because I'm a bastard, right? Yes. That's a good first answer. Because I'm a bastard?
No,
No. Why?
because then you don't want to tell other classes.
Slightly worse answer.
Because you never know your full population.
Because the deck that I played with yesterday represents the full population of what's out there, what you're studying. Sure, it's in a named deck of cards, and later on today we're going to spin pennies. These are inane experiments. But the procedures we're using in them represent what's actually going on when you do a statistical inferential study. You don't know your population. You get a snapshot of that. And from that snapshot, you can build inferences. But you never get to see the population like my deck of cards. So I love the questions and I love the implications. I love that too. Tell me your name one more time.
Tracy.
Tracy, I was going to call you Emily. You said something the other day about the Excel spreadsheet. Well, you have it set up. You must be ready to talk.
No, it was never about the Excel spreadsheet.
Oh, it was about the spreadsheet. I'm sorry, I thought it was. But I've had that discussion too. Well, you wouldn't have built the spreadsheet if... I'm like, sure I would have, because people were accusing my deck. So I had to build another piece of evidence to show that my deck might be okay. Not is, not isn't, but might be. Because it's all probability. It's all might. How do we measure, how do we metric that might? That's what it's all about. Hence why you guys are pulling cards out of decks. So thank you. So let's go over here. Let's collect our data. And this is, we're going to replicate this in that quiz for next week. And hopefully it's going to be fun. We're going to see some similarities in the results of Excel versus what you just did. Hopefully.